I want to do one more example for the measures of dispersion. Here I've got, it's kind of sad, I've got the Detroit Lions 2021 scores up to this point in the season. Currently it's this fall of 21. And so they've played 11 games up to this point. We're just after Thanksgiving where they played the Bears and lost. In fact, all of these games are losses, except for the Steelers where they tied. Kind of unfortunate there. But anyway, you can kind of see their scores throughout the season. So their opponent is on the left, but the Lions' actual score is on the right. Here is what I was writing down. And you can see they didn't even get out of the teens except for the first game of the season. So they haven't even reached 20 points in any other game this season, including an overtime game, or whatever that was, double, triple overtime, however they play that. I can't remember. But anyway, where they ended up tied. And so what I'm going to do is try to figure out what their standard deviation is of their points for the season. Up to this point anyway, first 11 games. And so, and actually I'm also going to look at the range as well. So we'll do both the range and the standard deviation here. So let's start with the range, in fact. Remember that the range is equal to the highest minus the lowest value, okay, from the list. So the highest value is obviously the 33 they put up in the first week, and the lowest is the 6 that got really destroyed by the Eagles that game. And so the range here is going to be 33 minus the 6, which is 27, right? So they have a 27-point range to their scoring for each game, all right? Okay, so that's that. That one's not too bad. It's the standard deviation that can give problems. So that's where we're going to spend most of the time here. The standard deviation before, just kind of as a setup, we can't do anything until we have the mean, right? The mean is important because the very next calculation in our table, and I like to use a table to organize our thoughts, otherwise it gets very messy as what numbers we're adding when and squaring when and all this stuff. So nice to use a table to do this. So I need the mean in order to do this calculation. So that's the next step. We'll start there. And what I need to do is add up. Remember, the mean is the sum of the x's. So I have to add up all the x's together. And 33, 17, 17, 14, 17, 11, 19, 6, 16, 10, and 14. That's 174, okay? So that sum is 174. So that goes in the numerator, and I'm dividing by 11. Our end value is 11 because there's 11 games, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yep. Okay? And so 174, divide that by 11, is 15.818181. It's a repeating decimal. So I'm just going to round that at 15.8. So approximately 15.8. That'll get us close enough. All right. Now, you may be asked to round to different places depending upon the problem in the homework or on the test. If it doesn't specify where to round, especially on a test, I would be pretty lenient on that one. If you wanted to go with 16, you could, okay? So they're scoring just under 16 points per game, okay? Now, if you want to find the difference here, this is the difference between x and x bar, you just subtract the x value minus x bar, or the mean, okay? So it's gonna be 33 minus 15.8, which is 17.2, and these are all going to have decimals now because I introduced the decimal on the mean. So 17 minus 15.8 is 1.2, and some of these are going to be repetitive. Anywhere there's a 17, which seems to be the mode, right? The mode is the most common score. So I see 17 show up a lot. 14 minus 15.8 is negative 1.8. 11 minus 15.8 is negative 4.8. 19 minus 15.8 is 3.2. 6 minus 15.8 is negative 9.8. Then we have 16 minus 15.8 is going to be 0.2. 10, let's see, 10 minus 15.8 should be negative 5.8. And then 14 minus 14, I did, it's negative 1.8. Okay, now I don't have to add up just yet. So I take those values and square them, right? So the next column of our table is going to be this distance, or difference, I should say, squared. And when you square it, you eliminate all the negatives, essentially. That's an important part of this. So we take 17.2 and square it. Now really, it would have been easier if I had just done this from the beginning, right on each line. So this might be good advice for you as you're doing this, is to calculate that distance, 17.2, and then just hit square on your calculator and then enter this one in. And then you don't have to go through and type all this again, which I'm doing, which is not the most efficient process. 1.2 squared is 1.44, I knew that one. And 1.44 there, and 1.44 there, and 1.8 squared is 3.24, 4.8 squared is 23.04, 3.2 squared should be 10.24. Yeah, and then 9.8 squared, 96.04. And then 0.2 squared should be 0.04. 5.8 squared, 33.64. These all ended in 4? How odd. That is odd to me. Why are they all ending in 4? Huh. Well, I guess, oh, they're all 8s and 2s. 2 squared is always a 4, and 8 squared is 64, so I guess that makes sense. And then the 1.8 already had 1.8, that's 3.24. Okay, so here, at this point, this column in the table is where we want to add up. So remember our standard deviation formula is the sum of the squares of these distances or differences. So you do the differences, you square them, and then you add them up, okay, the sum. So we add all these together. So 295.84 plus 1.44 plus 1.44 plus 3.24 plus 1.44, 23.04, 10.24, 96.04, 0.04, 33.64, 3.24. All right, and that is 469.64. All right, so there's our sum. We're going to take that sum and put it in the numerator. So our standard deviation is going to be the square root of that number, 469.64, over n minus 1. Now remember, n is 11, so n minus 1 would have to be 10. I love dividing by 10, you just move the decimal. So that is the square root of 46.964. And I get approximately 6.8, 6.85. We'll go 6.9. All right, that's going to be good enough. So our standard deviation is approximately 6.9 for this set of data. So basically what that means, just to give you just a brief look at this. So their scores are averaging just under 16, right? 15.8. So that's kind of your center of all the data. So if you look at the spread of the data, that's kind of your center. And then the 6.9 gives you how far the main grouping of data is from that center, okay? So it's 6.9, almost 7 on either side. So you can say that almost all of the data, and there's a certain percentage of the data that we can typically assume is in there, but a vast majority of the data is going to be, give or take a standard deviation from that mean. So if you started at the mean, which is around 16, and you add and subtract 7 points from that mean, roughly 7, you'd be 16 instead of 23. 16 minus 7 would be 9. So almost all the data values are between 9 and 23, which is true. In fact, all but 2 of them, the highest and the lowest, are the only ones outside of that 1 standard deviation from the mean, okay? And if you go with 2 standard deviations from the mean, you'll pretty much encompass everything. You'll be very close. If you went 2 standard deviations, which would be 14 away, that would be 30. We didn't quite grab this one, so you're not quite to that one. But you would encompass the Eagles score. So you get one more value if you went on the other side, right? If you subtract 14, you'll get down to 2 basically. So yeah, you get the Eagles involved in that one. So anyway, just an idea so you can kind of see what that means. You start with your mean, and then your data is grouped around really 1 standard deviation on either side of that mean will give you the vast majority of the data. If you go 2 standard deviations, you almost catch everything. And then periodically there will be some outliers outside of that. So that's what the standard deviation is typically used for, is to determine how far from the mean the vast majority of the data is.